Hi guys, welcome back to lesson number 10 on Calculus AB, where we're talking about the chain rule. And we've done two videos now. One were just introduction to chain rule with a couple of examples, and the second video we did a lot of examples for derivatives with the trig functions. So in this video, I just decided to do a couple more examples for you just so you guys can see more stuff. So go ahead and get started with the example number 6, where it says y equals the square root of 3x squared minus 5x. And so in the previous two videos, I have rewritten so many functions, and I'm going to keep rewriting the functions just because it's just nicer to do it this way. So anything raised to a square root or under a square root is raised to the 1/2 power. So when we find this derivative using the chain rule, again, we're going to move down 1/2. And again, for the millionth time I've said this, we're going to leave everything inside of the parentheses alone. And then we're going to subtract 1 from the exponent. So again, we get -2. And then again, ladies and gentlemen, our focus is going to be on what the derivative is inside the parentheses. So the derivative of 3x squared is going to be 6x. The derivative of -5x is -5, and there is our answer. And if we want to rewrite the question, or actually simplify the question, which is most likely what you would do if you were to, what it would look like for multiple choice, right? If there's a multiple choice question, it would look something similar to this, right? So the 6x minus 5 is in the top, the 2 is in the bottom, and then we have the 3x squared minus 5x to the 1/2 power, or the square root of in the denominator. All right, so there is that example. For example number 7, we're going to use the quotient rule. Okay, we can use the quotient rule for this problem, and what we're going to do is take the denominator and we're going to multiply by the numerator. Now this is a very interesting function because students see that e and they get confused. So we're multiplying by this. We're going to again move down the 3. We're going to write 2x plus e, and we're going to subtract 1 power, and then we're going to multiply by the derivative of this. Right, multiply by the derivative of this. Well, the derivative of this, the derivative of 2x is just going to be 2. And ladies and gentlemen, e is just a constant. It's a number. E or pi, it's going to be 0. This derivative is going to be 0. Students will think, oh, it's just 1e. No, it's just going to be 0. So we do that, all right? That's what we're going to do for that problem. And so we're going to do denominator times the derivative of the numerator minus the numerator. And then we're going to multiply that by the derivative of your denominator, and then all over your denominator squared. Now be careful here, 3x squared. Do not write 3x squared. That is bad. We do not want to write that at all. We want to write, instead of that, either 3x quantity squared, which is nice, or we can write 9x squared, right? 9x squared. And I'm going to be able to leave that alone. I mean, we could take out a 3 here, a 3 here, and 3 here, but my goal is not really to simplify. My goal is really just to show you guys how to do the problems. And at least now you probably know what's going on. For example number 8, we're going to use the product rule, right? The product rule. So again, let's just set this one up. We're going to get y prime. We're going to do the first. This is raised to the 1/2 power. So when we find the derivative of this, it's going to be 1/2. 5x minus 1 in the parentheses to the -1/2 power, and then we're going to multiply by the derivative inside of the parentheses. So first times the derivative of second plus the second times the derivative of the first. And that is it. That is it for us in that problem. All right, I'm going to change this little plus right here. Just make sure it looks a little bit better for us. So we're good to go. I'm not going to do number 9. It's very challenging, but this example, we have the product rule, the quotient rule, the power rule, and the chain rule. It's just a hot little mess, and it's just not relevant. So we're going to move on to some multiple choice questions. Okay, so I thought it'd be interesting to do some questions that are multiple choice. So let's look at some stuff like this. So this question came from the 1972 BC exam, question number 6, where it says, given that the derivative of f of x is g of x, and that h of x is equal to x squared, what's the derivative of f of h of x? So I like this example because this is the chain rule, right? We're going to find the derivative of a function inside of a function. So the derivative of this is going to be equal to, so the derivative of our function f of h of x is going to be equal to the derivative of our overall function where we leave everything inside of the parentheses alone. You see how I'm saying this now, right? So we take the overall function, leave what's inside the parentheses alone, and then we're going to multiply by the derivative of our actual inside function. And that's what the chain rule is. That's exactly what the chain rule is. So then when I do this, well, I know that the derivative of f is g. So this is just going to be g of h of x, because f prime is equal to g. And then the derivative of h prime of x is just going to be 2x. So we have to look down here. We're not completely out of right now. Out of the water. What am I trying to think of right here? Out of the woods? I think that's right. Yeah, I'm leaving it in. Out of the woods. That's what I'm trying to say. I think. So we know what h of x is. We know h of x is going to be x squared. And so we get this. And so we finally get the answer, which is going to end up being C. So this is a really good, just simple, well, not really simple, but just a good example of what the chain rule is. I've got the chain rule for that one. For question number 23. So this one I like because we haven't seen one quite like it before, where we have an exponent and we have then underneath a root of a cubic root. So just like the many examples I've done prior to this, we're going to rewrite this as cosine of 3x, and then we're going to raise it to the power first and then the radical second. So it's going to be 2/3. And then, ladies and gentlemen, just like before, many times before, when we find this derivative, we're going to pull the 2/3 down. We're going to rewrite this, or say keep this, leave it alone, cosine of 3x by itself, to the negative 1/3 power. And then we're going to focus on the derivative of this, which is going to be negative sine. And then I always like to put parentheses on that, so it's negative sign, not minus sign, right? So it's going to be negative sign. We're going to leave this alone, and then we're going to multiply by 3. Right? So this is our actual answer for our derivative. So let's start canceling stuff out and see which one of these we get to. So the first thing that we're going to start canceling here is going to be the 3's. And then I don't see anything else that I can really cancel out. So let's just go ahead and do what we got to do for this problem. So f prime of x is equal to 2. And then notice that this is in the numerator, right? There's no negative exponent here. So it's going to be negative 2 sine of 3x on the top. And then we have cosine of 3x all raised to the 1/3 power down here. So we can just say this one looks, nope, that's got a 3 in it. This doesn't have the sign in it. These don't have the sign in it. So this is probably the right answer, negative 2 sine of 3x over cosine. Yeah, and they just rewrote it again to the cube root function. So again, we got another C. It's always about the C's, right? C, C, C. All right, we got 2 more to do. 2 more examples to do. This question, again, like it, it's very similar to question 22 that we just did here. We're going to look at this and talk about the chain rule, and this is a straightforward plug and chug. So the derivative of our composition would be, again, f prime of g of x, and then we're going to multiply by the derivative of g of x. And that's it. That's all we do. So there's a lot of information we're not even going to use here, right? So we're going to do h prime of 1. And so we're going to look at f prime of g of 1 times g prime of 1. All right, so let's start simplifying this. So we know from this part that f prime of g of 1. So what's g of 1? Well, g of 1 is 2. So we want to find f prime of 2. And we're going to multiply that by g prime of 1. Well, g prime of 1 is negative 3. And then f prime of 2, again, we're just looking at f prime of 2. F prime of 2 is negative 4. And so negative 4 times negative 3 is going to give us the answer of 12. So finally, not a C, we get a B. We get a B. Last example, and it's a good old unit circle problem. So we have to evaluate. Sometimes we have to evaluate. So for the last time in this lesson, ladies and gentlemen, I'm going to rewrite this one more time as the sine of 4x raised to the 3rd power. We should be superstars at the chain rule by now. So f prime of x is going to be equal to, I'm going to move the 3 down. I'm going to rewrite sine of 4x squared. And then I'm going to multiply by the derivative inside of my bracket here, which is going to be cosine of 4x. And I'm going to multiply by my function, derivative of 4x, which is 4. And I'm going to go ahead and plug in pi over 3. Why not? Let's go ahead and plug in pi over 3. But before I do that, I'm going to go ahead and just do the 4 and 3. I'm going to go ahead and just do 12. So this is going to be sine of 4 pi over 3. And I want to square this. And this is going to be the cosine of 4 pi over 3. All right, so let's actually solve this problem. So f prime of pi over 3 is going to be equal to, 12. So I always tell students to do it this way. Well, first of all, we know the answer is going to be positive, right? It's going to be squared, so we know the answer is going to be positive. So the sine of pi over 3 is the square root of 3 over 2. Technically, it's negative because we're in quadrant 3 here, but we don't care because it's positive. So it's going to be negative square root of 3 over 2. So negative square root of 3 over 2 squared is just going to be 3 over 4. And technically 3 over 4 is, it's technically going to be negative, but then we square it, it's going to be positive. So we're going to have 3/4 right here. Then cosine. So cosine of pi over 3 is 1/2. And so 4 pi over 3 is going to be, and this is what's important with this part, with the signs, then we're in quadrant 3. So cosine of 4 pi over 3 is going to be negative 1/2. So then we finally get our answer down here. We're going to get that this is boom, boom. We're going to get that this is going to be 3, right? 4 goes into 12 3 times. 3 times 3 is 9 over 2. So negative 1/2 times 9 is going to be negative 9/2, which is going to give us our answer as B. So that is a lot of chain rule. I hope that you guys understand that. How many times have we rewritten stuff? We take the derivative of the outside, then the inside, and then even sometimes there's more inside, the inner inside. So hope you guys think that's helpful, and I'll see you guys in the next video.